Okay, in this lecture we will discuss cleaning data. Here's our lesson objective. Alright, so data will sometimes have values that are missing. And why does this occur? Well, there could be errors in data collection. There could be errors in manual entry. Someone just forgot to fill something in or type something in. Or maybe they were copying from something handwritten and they couldn't read the person's handwriting. It could be that the data set is a combination of multiple other data sets, and the other data sets didn't completely overlap for certain fields. And sometimes the information was just plain not known. So in this course we will often use pandas to deal with our data, and when there's missing data you'll see this NaN symbol in its place. And how do we deal with this? Because that's not a number, it's not a categorical value, you can't really use it in a machine learning model. And so these are the kinds of issues you could get with feature generation. Depending on what software package you're using, it could skip the entire sample, it could raise an error, or it could just set it to 0. And you need to understand how your software, how your machine learning model is going to handle those, or even better, handle it yourself first before that data is input into a model. Now, the good news is Pandas in particular is well equipped to support dealing with missing data and setting it to values based on whatever you desire. In this lecture, we're going to kind of explore how you want to replace values that are missing in the data set with different things. So the first is, well, let's just set it to 0. Now, is that a good idea? And, the answer, like many of the answers, is this depends. And it also depends what does 0 mean. Now, it may be that 0 might mean that there's no information there. So let's say this is some sort of categorical value that is on an ordinal scale, and 0 just is the lowest level. It just means the information wasn't available, like someone's checking unknown in a survey. In that case, that might be a really good way to do business. But if it's a value and we're going to use it in something like a regression model, then in that case it might not work. So we have to look at other things besides this simple approach of setting to 0, and one is called imputation, and this means to set the value to a certain type of statistic of everything else, of all the other samples that have that value in the column. So let's set it to the average. But again, whether or not this works is going to depend on the domain, because it could be that if something has the average value for a certain feature, and if one of the other features is has a certain property, then a machine learning model might combine those two bits of information and make a prediction. And it's really hard to make a determination of if a model is going to go ahead and do that or not. And so setting it to something like average, I think it requires two things. One is understanding the domain, and two is I would also maybe approach this as something to test out a bit. So if you're using this as training data, maybe take a subset of the training data, train a model, and see what happens when you feed that model an average value. So, a little story about imputation. So when I was running a machine learning-based startup, we were predicting software vulnerabilities that would be exploited by malicious hackers. And we were combining a large number of disparate data sets, so missing values would be something that would often come up. We had one type of scoring mechanism that came from the government for vulnerabilities that wouldn't be provided in a timely manner because the vulnerability would have to go through some kind of certification process. Initially, our engineers were setting it to an average value, and we found that this was leading to a lot of false positives by our software. And going back through and kind of tearing apart step by step how the machine learning model was providing those predictions led us to those features being the source of those predictions. And then we found right away it was due to imputation. And so we had to come up with other means to work around it. What we actually wound up doing was having two separate models, one that would assume that that feature was present and one that would assume the feature was not. And in the model that assumed the feature was not, this was akin to just getting rid of that whole column. So next is dropping the row, and this is when we had our model that was trained that would assume that the missing value was not missing. We would simply train the model on all rows in the data set that had a legitimate value. And this is very easy to do. You can use something in pandas called drop NA, but one thing to keep in mind, if that data is substantial, you are reducing the size of your training set. Now, what we had done is we had one model that had this dropped, and then we had a different model where instead we did something else. We dropped the column that we'll talk about in a moment. So here's the pandas command, and here's dropping the column. So dropping the column means here we're going to just get rid of that feature altogether. There's too few samples in the data set that doesn't have that feature value, so we don't want our model to get hung up on something that we don't have a lot of information of, so let's just get rid of that column altogether. And this is also very easy to do in pandas. There's a command called delete, which allows you to delete columns. So again, in pandas you can have multiple copies of the data frame, and like I said, we would do this only for the data, the subset of the data that was missing that feature value. We drop the entire column. The rows that did have the feature value, we may or may not have considered it for this auxiliary model, but we had this model that was designed to handle the case where that information was not yet available. So the key things to remember when dealing with data cleaning is you need to understand how often the missing data occurs and why it occurs, as well as understand the domain aspects of your problem. So it was really key for us to know that, hey, this was a feature value, setting it to average doesn't make any sense based on the domain, and we know it's not there because that information doesn't come out for a certain amount of time. And then what the approach we took was designing models that could or couldn't handle the missing feature. So this concludes our lecture on data cleaning. Stay tuned for more content.